All right, diving in today, we're going deep on something super important for learning, and that's how working memory and reading difficulties are connected.
Yeah, absolutely.
We've got a great paper to guide us. It's from 2007 from Educational Psychology Review by Savage, Lavers, and Pillay. It's pretty detailed.
It is, and for our listeners out there, we're aiming to give you a really solid understanding of this connection. It can be pretty complex. So consider this your crash course on the research, what's still being debated, and really what matters most, all without getting bogged down in, all that technical stuff.
Exactly. And we want to show you why this should matter to you. Because if you understand how working memory plays into reading, it can actually give you some unexpected insights. Not just the learning process, but also where some of the roadblocks in reading might be coming from.
Absolutely.
So we're going to break down the main ideas in a way that's hopefully pretty easy to grasp.
Yeah, and the paper actually gives us a good framework for our deep dive today. It focuses on four main areas. First, how do we define and measure working memory?
Right.
Second, what's the specific role of working memory when we're learning to read? Third, are the issues we see with working memory really all about language? Or are they something more general? And lastly, how does working memory function in kids with reading difficulties compared to those with ADHD?
Okay, so plenty to unpack.
Lots to cover, but all aimed at giving you a clearer picture.
So let's jump right in. First things first.
Mm-hmm.
How do we even define this thing called working memory?
Right.
The paper starts by explaining that common understanding, which is that working memory is like our mental notepad, right? It's that system we use to hold on to information and then actually do something with it for short periods when we're doing anything that requires mental effort.
Right.
So, like figuring out a tip in our heads or following the plot of a movie or a book.
Yeah, that's a great way to put it. Right. Yeah, and it's also important to understand the difference between working memory and short-term memory. So short-term memory is really about just holding on to information. Like, if you're trying to remember a phone number just for a few seconds, that's your short-term memory.
Right.
Working memory goes beyond that. It adds that processing part, like manipulating the information, not just storing it. And the paper also mentions that short-term memory is often considered to be more specific.
Right.
Like, for example, you might have a good memory for, remembering lists of words,
Right.
but not so good with remembering like visual details. So there's some specificity there.
And that brings us to Baddeley's model.
Yes.
Which the paper really emphasizes as a big, influential way of understanding working memory.
Right.
So could you give us the rundown on that model?
Yeah, absolutely. So Baddeley's initial idea had three main components. First, there's the central executive. And this is, think of it as the brain's CEO. It's in charge of coordinating information from the other systems.
Right.
It helps us switch gears mentally, focus our attention on what's important, and even pull in relevant knowledge from our long-term memory to help us tackle a task.
Okay.
Now, along with that, we've got the helper systems. There's the phonological loop. This handles verbal information, anything that has to do with sound.
Okay.
So imagine your inner voice repeating something to yourself. That's your phonological loop in action, along with a temporary storage space for sounds.
Right.
And then there's the visuospatial sketchpad.
Okay.
This one handles visual and spatial information. So like if you're mentally picturing your route to work, that's your visuospatial sketchpad at work.
So it's like the phonological loop is like a little audio recorder in your head that you can replay, and the visuospatial sketchpad is like a mental whiteboard.
Yeah, precisely.
Right, where you're drawing or visualizing things.
Exactly.
Okay.
And later on, Baddeley actually added a fourth component called the episodic buffer.
Okay.
Now, think of this as the part of your working memory that kind of tries to put it all together, create a coherent episode or story
Okay.
by pulling information from the phonological loop, the visuospatial sketchpad, and even your long-term memories.
Right.
So it's believed to be really important in how we experience and retrieve information consciously.
It's like our brain trying to put together a unified experience
Yeah.
out of all these different bits of information it's processing.
Yeah.
Okay.
Makes sense.
Now, the paper also talks about another model
Yes.
by Erickson and Kinch. It's called long-term working memory.
Right.
How does that model kind of fit in with all of this?
So that model proposes that we can actually use our long-term memory, that's like our vast storehouse of knowledge, right, to boost our working memory. The idea is By quickly pulling in things we already know, we can update and remember new information more easily.
Okay.
Now, while this idea is really important in understanding how experts in different fields can handle complex information, the paper does point out that it hasn't been applied much to understanding reading difficulties in children.
Okay.
And that might be because many kids who struggle with reading don't necessarily have problems with their overall long-term memory.
Okay, so we've got these different ideas about what working memory is.
Yeah.
But how do researchers actually try to measure it?
Right.
In kids and adults? The paper talks about a whole bunch of different tasks.
Yeah, it does. And this is a really important point because the paper brings up some concerns about how reliable some of these common measures really are.
Okay.
So let's start with complex verbal span tasks, like the listening recall task. In this task, you'd hear a series of sentences, and then you have to remember the last word of each sentence in the order they were presented. And this is supposed to measure both your ability to process language and your verbal memory span.
Yeah, we've seen other versions of this too.
Mm-hmm.
Where you have to decide if a sentence makes sense or answer a question about it or even fill in a missing word at the end.
Right.
And then there's the sentence span task, which adds a visual component along with the spoken sentences. And the reading span task, where you're actually reading the sentences and have to recall that final word.
Exact.
Sounds like researchers have come up with a lot of different ways to test this.
Yeah, they definitely have. And we've also got the counting span task and the star counting task.
Yeah.
Bringing in those nonverbal elements, asking you to hold on to one kind of information while doing something else entirely.
Okay.
But here's the thing. The paper highlights some pretty significant concerns about these complex span tasks. One of the biggest ones is ecological validity, which is basically asking, do these, kind of artificial tasks really reflect how working memory works in real life situations, like when you're reading a book or having a conversation?
Right. It's like in a lot of these tasks, you're trying to remember words that have absolutely nothing to do with the next sentence you have to process.
Exactly. It's not how we naturally use language.
Right.
Another issue is that these tasks often focus so much on how much you can store without really looking at how well you're processing and manipulating information at the same time.
Right.
Somebody could be doing well simply because they're good at switching their attention back and forth.
Right, yeah.
Between trying to cram those words in and actually understanding them.
Okay.
And the level of actual processing required in some of these tasks is also a bit questionable. Like, if you just have to fill in a really obvious missing word, are you really thinking that hard?
Right. So if that processing part's too easy, the task might really just be a measure of short-term storage, not the active working part of working memory.
Exactly.
Okay.
And the paper also points out that some of these complex span tasks aren't very consistent in their results.
Right.
Either over time or even within the same test, which raises questions about their reliability. And when researchers use factor analysis, which is a statistical technique to see if different tests are actually measuring the same underlying ability, sometimes these complex span tasks group together, suggesting there's this general working memory skill. But other times, they seem to be tapping into more specific abilities, like separate verbal and visual executive functions.
Okay, interesting.
And then how much you already know can also have an impact. Many of these tasks require some level of general knowledge, so your performance might depend on how easily you can access your long-term memory, not just your working memory capacity. And lastly, if the tasks use words, then people who have trouble finding the right words, which is common in poor readers, could be at a disadvantage.
Yeah, so many potential issues. So it sounds like these tasks that seem pretty simple at first glance are actually pretty tricky to interpret.
Yeah.
So if those complex span tasks have those limitations, what are some other ways researchers try to get at working memory?
Well, the paper talks about alternative, like backward digit span, where you have to repeat a sequence of numbers in reverse order. And this is thought to place more demands on that central executive.
Right.
We've also got dual processing tasks, the Wisconsin card sorting task, which is a bit different. It tests your ability to switch rules, and then all sorts of other measures that researchers have designed. But the problem with this variety is it makes it hard to compare findings across studies. It's like everyone's speaking a slightly different language.
It's like trying to compare apples and oranges. What about the simpler tasks?
Right.
Like just repeating a list of digits or words? Those seem, less complicated.
Yeah, they do seem simpler. But the paper points out that while forward digit span, which is repeating numbers in the order you heard them, That's considered a basic measure of the phonological loop. And backward digit span gives us a rough idea of central executive function plus the phonological loop. They often aren't very sensitive, and they don't really predict how well somebody reads, whether they're typically developing or struggling. Word span, where you try to recall a list of words, that's included in some test batteries. But it also hasn't consistently shown a strong link to reading or spelling.
Okay.
Interestingly, some research suggests that how well you do on a word span task might actually be more related to your ability to process information at the level of a whole text, rather than just reading individual words.
Oh, that's interesting. I wouldn't have thought of that. So, like, remembering a list of words might be more about that overall language processing
Yeah, exactly.
than about the really basic mechanics of decoding the words.
Yeah. And then we have nonsense word repetition, or NWR, where you have to try and repeat made-up words that sound like they could be real.
Right.
And this has been a really popular way to study the phonological loop as a possible mechanism for learning language, because it's thought to tap into your long-term memory for how sounds are structured, your ability to hold on to the new sounds in the phonological loop, and that central executive to kind of organize your response.
Right, but the paper also talks about a debate about what exactly NWR is actually measuring.
Absolutely. Some researchers argue that it relies heavily on your ability to actually say the sounds correctly, what's called output phonology, rather than just your verbal working memory.
Right.
And to try and get around this, researchers have developed something called nonsense word matching, or NWM, where you see or hear two lists of made-up words and you have to decide if they're the same.
Okay.
And this puts less emphasis on speaking, and it's thought to be a purer measure of the phonological loop.
Okay.
Interestingly, how well you do on NWM and NWR only shows a moderate overlap. And sometimes NWM is a better predictor of how well kids are doing early on in school.
Right. Which suggests that they might be tapping into slightly different underlying skills.
Okay.
And one study even found that people showed a word likeness effect when they were just identifying non-words without having to say them, suggesting that this effect isn't solely due to the difficulty of producing those sounds.
So even with these seemingly specific tasks, like NWR and NWM, there's still a lot of uncertainty about exactly what they're measuring.
Yeah, and the paper concludes that even though these popular working memory measures often show some kind of connection to reading ability, we still don't have a very clear understanding of what exactly they're measuring, what's called their construct validity.
Right.
And those simpler short-term memory tasks, they have even weaker links. So the big takeaway here is that we need better, more reliable ways to measure working memory if we want to really grasp its role in reading development.
Okay, so we've covered how working memory is defined and measured.
Yeah.
And, we've seen that it's complex.
So now let's move on to that second big question the paper addresses, which is, what is the unique role of working memory in learning to read, especially when we're considering other things we know are important, like knowing your letter sounds, being able to hear and manipulate the sounds in words, that phonological awareness, and rapid serial naming, being able to quickly name things in a series.
Right. So here we're trying to figure out whether working memory is doing something above and beyond these other skills. We know, for example, that difficulties with processing the sounds in language are a key feature of dyslexia. The paper talks about the idea put forward by Tunmer and Hoover that working memory, specifically how well we can hold on to and work with sounds in our memory, is actually built into some phonological awareness tasks, like when you're asked to, take a sound away from a word,
right?
Like saying cat without the K.
Yeah, like if you're asked to say bike without the B, you got to keep that Ike sound in mind, the A and K sounds, while you're taking away that B.
Yeah. And that definitely sounds like it's using working memory.
Right.
Yeah. However, more recent research has suggested that different types of phonological awareness tasks might rely on slightly different skills. For example, tasks that explicitly ask you to delete a sound that might tap more into the central executive.
Okay.
But more implicit tasks, like identifying which word doesn't rhyme in a set, might be more about the phonological loop.
Okay.
So it seems the type of task and how developed the child's reading skills are, those can both play a role.
Okay, so what about the connection between these phonological processing skills and short-term or working memory? As kids get older and their reading develops, how does that relationship change?
Well, the paper mentions that how well those two things are connected tends to be pretty modest in those early school years,
Hmm.
and there might actually become more distinct as those reading skills mature.
Hmm.
When researchers use factor analysis, remember that statistical technique we talked about, phonological processing and working memory, they often appear as separate underlying abilities. However, there's also a perspective that sees phonological working memory as really being a part of that bigger picture of phonological skills for reading.
Okay.
Like how efficient we are at coding and storing those sounds in our working memory to help us decode words.
So instead of thinking of them as two totally separate things, it might be that phonological working memory is actually a critical component of that bigger set of phonological skills that are so important for reading.
Exactly.
Okay.
And when researchers follow children over time, those longitudinal studies, they often find that how well kids do on those phonological loop tasks doesn't really predict how well they'll be able to read words later on, once you've already factored in their other phonological skills.
Okay.
However, complex span tasks, those that combine processing and storage, sometimes those do predict reading comprehension later in development.
That's an interesting difference. So the basic sound-based memory might be less of a unique predictor for just reading the words, but those more complex working memory skills seem to matter for actually understanding what you're reading. What about spelling? The paper mentioned we don't have as much research on that.
Yeah, that's true. But the paper suggests that spelling might actually place greater demands on working memory than those early reading skills.
Okay.
One study found that how well children did on short-term and working memory tasks actually predicted whether they would have below average spelling, even after the researchers had taken into account their phonological awareness and rapid naming.
Okay.
Which, intuitively makes sense when you think about it. When you're spelling, you often have to hold those sounds in your mind and actively manipulate them as you're trying to match them to letters.
Right, that does seem like a more active role for working memory.
Uh-huh.
Now, the paper also touches on a theory by Palmer that involves inhibitory functions. What's the gist of that?
So, Palmer proposed that reading difficulties might arise because some people have trouble with the brain's control processes. Specifically, being able to access the sound-based information for reading while at the same time suppressing the visual information.
Yeah.
She called it a dual coding issue. And her research found that teenagers with dyslexia showed effects of visual similarity on a memory task with pictures, whereas typical readers showed effects of sound similarity,
Okay.
suggesting that the dyslexic readers were still relying more heavily on visual information rather than sound-based information when they were trying to remember.
So it's like maybe poor readers are having trouble prioritizing that sound information, which is key for reading,
Right.
and maybe getting distracted by how the words look.
Yeah, that's the general idea. But the paper also presents some reasons to be cautious about this theory. For example, there isn't a lot of strong evidence showing a direct competition between verbal and visual processing in the way that Palmer described. And our current models of working memory suggest that that integration of visual and sound information happens in that episodic buffer we talked about, not necessarily through the central executive via inhibition. And studies where people have to do two things at once haven't always shown the kind of interference you would expect if there was this strong competition. And plus, a lot of Palmer's research was cross-sectional, looking at kids at one point in time rather than following them over years.
So while the idea of needing to control your attention sounds plausible, the specific way that Palmer connected it to reading difficulties through inhibiting visual information is still something that needs more evidence.
Exactly. So the takeaway from this section is that while working memory, especially that phonological loop, is definitely involved in reading, it doesn't always stand out as a unique predictor of basic word reading when you already consider those other core phonological skills. However, complex working memory tasks, they do seem to predict reading comprehension, and spelling might have a stronger link to working memory, even more so than early reading.
Okay, so we've explored how working memory is defined, its unique contribution to reading. Now let's get to that third area. Are those working memory problems we see in poor readers specific to language, like dealing with sounds and words? Or are they more general, affecting their ability to hold and manipulate different types of information, like visual details, spatial stuff?
Right, and this is where it gets really interesting. We've got several different models. One idea is the general capacity model. This one suggests that your working memory has a limited overall capacity. how much you can hold and process, regardless of whether it's words, pictures, numbers, whatever.
Okay.
And this idea is backed by studies that found connections between how well people do on those different complex span tasks and their reading comprehension.
So if you have a smaller working memory capacity in general, it'll affect your ability to do lots of things, including reading.
Yeah, that's the thinking. And then we have the general processing model, which suggests that reading difficulties stem from a more general difficulty in processing information efficiently.
Okay.
So this model would predict that how well you do on complex span tasks would relate to your reading regardless of what kind of information the task uses. But this idea isn't as well supported because we often see that poor readers have really specific difficulties with remembering verbal information.
Makes sense. If the problem was just a general slowness in processing, you probably wouldn't see these specific issues with remembering spoken words.
Right. Then there's the specific processing model. This argues that how much you can hold in working memory really depends on how efficient you are at the specific mental processes needed for the task.
Okay.
And this model is backed by studies showing that tasks that are specific to a domain, like verbal memory tasks, are the best predictors of comprehension skills in that same domain, like understanding spoken language.
So if you're struggling to follow spoken instructions, you might also have a smaller capacity for holding verbal information in your working memory.
Exactly. And lastly, we have the phonological storage model. This one proposes that the working memory issues in poor readers are really specific to that temporary storage of sound-based information in that phonological loop. It's like a bottleneck that limits how much information can get through.
So if your phonological loop isn't functioning well, it's going to restrict how much sound information you can hold on to and manipulate when you're reading.
Precisely. Now, the paper points out that the evidence seems to lean a bit towards that general capacity model. Studies have found that kids who struggle with reading often have difficulties on both verbal and nonverbal working memory tasks. And one study even linked lower executive processing ability, that control center of working memory, to poorer performance across both visual, spatial, and verbal working memory tasks, which supports the idea of a more general limitation.
However, the paper also says that not all studies agree.
Right, that's true. Some research has shown that poor readers perform just as well as typical readers on those visual and spatial tasks, suggesting their working memory difficulties might be more specific to the verbal stuff. And the paper really highlights that who's included in that group of poor readers, like their IQ scores, if they have other learning difficulties, that can really influence the results. Studies with a broader range of kids with learning disabilities might be more likely to find those general working memory problems.
Right, and the type of reading problem probably matters too, right? Like someone who struggles to sound out the words is going to have different working memory challenges than someone who can read the words but just doesn't understand what they mean.
Yeah, absolutely. And the findings for reading comprehension, they're kind of mixed. Some studies support the idea that general working memory resources are important for understanding text, while others point to more specific verbal working memory skills as being key. For example, some research has shown that children who are good at decoding but struggle with comprehension, they actually have reduced verbal memory spans.
Okay.
And there's a growing interest in the role of what's called semantic working memory. That's how we hold and manipulate the meaning of words in reading comprehension. Some researchers have even suggested there's this thing called semantic short-term memory, which might be related to Baddeley's episodic buffer, but we need more research on this, particularly with poor readers.
So it sounds like we really need to look closely at the specific reading difficulties someone's having to understand this better.
Exactly. The paper also talks about how our reason for reading might interact with working memory. One study found that adults with lower working memory spans struggled more with study-oriented reading compared to reading just for pleasure, which might tell us something about the challenges kids face with their schoolwork. And finally, the role of being able to ignore distractions, those inhibitory processes linked to the central executive during reading comprehension, is also discussed. But the findings on that in poor readers are a little bit mixed.
Okay, so that question of whether those working memory problems are specific to language or more general, it's still not fully answered. Seems like there's evidence on both sides, and the answer probably depends on the specific reading skills we're talking about, how we're measuring working memory, and the individuals we're studying.
Yeah, that's a great summary. And how researchers design their studies, how they define and select their groups of poor readers, and whether they account for other learning difficulties, those are all crucial factors for understanding the results. So while some studies involving a wider range of learning disabilities suggest more general working memory limitations, more specific issues with processing and storing verbal information might be really key for those problems with reading words. And understanding text, that might involve a combination of those more general working memory resources along with the ability to process meaning.
Okay, so that brings us to that final area that the paper explores, which is how does working memory in children with reading disabilities compare to those with ADHD? So looking at these two groups can help us figure out, what cognitive difficulties they might share.
Exactly, because kids with ADHD also often experience reading difficulties. So comparing their working memory profiles can help us identify those common underlying cognitive challenges. It can also help us pinpoint specific deficits that might be more characteristic of one versus the other, which can have implications for how we diagnose and support these kids. And the paper notes that studying these groups can also help us evaluate different theories of working memory, especially those that emphasize that role of attention and executive control.
So what have researchers found when they've looked at working memory in these two groups?
Well, when you look at Baddeley's model, there's more consistent evidence suggesting that children with reading disabilities, they show weaknesses in that phonological loop.
Right.
Whereas this isn't typically the case for kids with ADHD. Some studies have even found that kids with ADHD who don't have reading difficulties, they don't show these phonological loop deficits. However, some other research has suggested that kids with ADHD do have problems with verbal learning or phonological memory as well. And when it comes to those tasks that tap those verbal executive functions, like remembering the last word of sentences, some studies have found those are more helpful in distinguishing between different ADHD subgroups.
So it sounds like the picture for verbal working memory is a bit mixed when we compare these two groups. What about visual spatial working memory?
Well, there is some evidence pointing to difficulties with visual spatial working memory in children with ADHD, which aligns with what we know about how those frontal areas of the brain are involved in both attention and visual spatial processing.
Hmm.
However, the findings here are also not completely consistent, with some studies showing no significant differences or even potentially better visual spatial skills in some kids with ADHD.
Okay, and what about that central executive? So important for attention and managing our thoughts.
Right. Well, difficulties with the central executive are often associated with ADHD. And some studies have found that kids who have both ADHD and reading disabilities, they do worse on tasks that are supposed to assess that central executive compared to kids who only have reading difficulties. However, a broader look at the research on central executive functions in ADHD shows a lot of variability, with some studies finding deficits and others not.
So it's not a clear-cut finding that problems with the central executive are always a key characteristic of ADHD.
No, it's more nuanced than that.
Hmm.
And one interesting twin study found that ADHD seemed to be linked to poorer response inhibition. That's the ability to stop yourself from acting impulsively.
Right.
While reading disabilities were more associated with phonological awareness and a general working memory measure. And in that study, response inhibition didn't seem to load with the working memory measures.
Okay.
However, more recent research has suggested that both reading disabilities and ADHD might involve challenges with processing speed and response inhibition, with processing speed being the more critical factor.
Right.
And our own research has echoed this, finding that how fast someone can process information seems to be more related to their literacy skills than their ability to inhibit responses.
That is really interesting. So it's not just about being able to stop yourself, but the actual speed of mental processing that's really important for both reading and attention.
Yeah, that's a key takeaway from some of this more recent work. However, we also have to remember that some studies do point to specific verbal executive function deficits in ADHD and how children with these conditions perform on those different types of working memory span tasks can vary. Methodological issues in this area are also significant, including how reliable the tests are for these populations, often small sample sizes, and the complexities of having those different groups, ADHD only, reading disability only, both, neither.
Sounds like really disentangling the working memory profiles of children with ADHD and those with reading disabilities requires really carefully designed studies and strong statistical methods.
Absolutely. And studies using those more sophisticated statistical approaches to look at underlying abilities, those have provided some support for Baddeley's model in distinguishing between these conditions. For example, reading ability has been linked to those phonological loop and central executive functions, while attention problems have shown connections to visual spatial working memory and dual tasking.
Right.
However, these studies also suggest that there might be some overlap between those central executive measures and tasks that look at speed and inhibition. And the speed of verbal processing might also be a factor in how well people do on those complex span tasks.
So there are some possible distinctions, maybe more visual spatial working memory issues in ADHD and more phonological loop issues in reading disabilities.
Yeah.
But that role of the central executive is still a bit of a mystery. And speed seems to be important for both.
Yeah.
It's a complex picture.
It is. And the paper highlights that we need more high-quality research, using clear ways of diagnosing these conditions, advanced statistical techniques, to really tease these differences apart.
So we've done a pretty thorough deep dive into the connection between working memory and reading difficulties.
Yeah.
Based on this really comprehensive 2007 review, let's try to summarize what we've learned for our listeners.
Absolutely. So we've seen that this connection between working memory and reading, it's complicated. And there are still ongoing debates about how to best measure working memory and the specific role it plays in different reading skills, like decoding words, understanding what you read, and even spelling. We also looked at whether those working memory difficulties are mainly about language or if they're more of a general cognitive challenge.
And for our listeners out there, some of the key takeaways might be that ongoing debate about what those complex span tasks actually tell us beyond just storage capacity. Also, that idea that our ability to hold and manipulate sounds in our memory, that might be really intertwined with our overall phonological processing skills rather than being something.